A pharmaceutical company just used AI to discover a new antibiotic in 48 hours, a task that used to take 5 years of lab work. And here's the part that keeps biotech students up at night. Where does that leave us? I've been off this channel for a while, but this topic pulled me back because no one is giving biotech students a straight answer. So today, that's exactly what we're doing. Let's talk about what's real. AI investment in biotech hit $5.6 billion in 2024, nearly tripling in 1 year. 62% of life science executives have already deployed generative AI in their workflows. And protein structure prediction, once a decade long challenge, is now a tool used daily by 73% of leading biotech organizations. This isn't a future thing, it's happening right now in labs, in pharma companies, in the very roles you're training for. So, what exactly is AI taking over? Number one, literature review. AI now reads and summarizes thousands of research papers in minutes. 76% of biotech labs have already adopted this. Number two, protein structure prediction. AlphaFold changed everything. What used to take years of crystallography can now be predicted computationally. Number three, drug molecule design. AI can now screen millions of chemical compounds and suggest candidates in hours, not months. Number four, repetitive lab tasks. Robotic systems handle pipetting, sample prep, and plate reading with almost zero error rate. And number five, clinical trial design. AI is being used to identify the right patient populations, predict dropout rates, and cut trial timelines significantly. Drug discovery timelines that once took 10 to 12 years are being compressed. Companies are reporting faster time to target, better hit rates, minor dead ends. So, yes, AI is doing a lot of what biotech professionals used to do manually. But here's what the headlines miss: every single one of those AI tools still needs a biotech professional to run it, validate it, question it, and decide whether to trust it. AI predicts a protein structure. A scientist asks, does this actually make biological sense? Is the model trained on the right data? What are we missing? AI flags a drug candidate. A researcher asks, what are the off target effects? How does this behave in a living system, not just a simulation? The UK's Wellcome Sanger Institute, one of the world's largest genomic centers, put it clearly: automation and AI now sit at the core of the science. But the skill that doesn't automate is judgment, knowing which question to ask, and knowing whether to trust the answer. And here's the data that actually matters for your career. Demand is rising, not falling, for people who can bridge biology and computation. Bioinformatics roles: computational biology, clinical data science, research scientist who can read an AI output and make a judgment call. The entry level roles that were purely manual, yes, some of those are shrinking. But the roles for people who understand both the biology and the tools, those are exploding. AI is not replacing biotech professionals, it's raising the floor of what you need to know. So, what do you actually do about this? Here are three concrete things. Skill 1: Bioinformatics Basics. You do not need to become a programmer, but you need to be able to work with biological data computationally. Python basics: working with sequence data, understanding what a pipeline does even if you don't build it yourself. NPTEL has free courses, EMBL EBI has free training, no excuse not to start. Skill 2: AI tool literacy. Know the major tools in your area. If you're in structural biology, AlphaFold, Rosetta, drug discovery, Schrödinger, BioNemo, genomics, tools like Benchling. You don't need to master them all, but being able to use one or two fluently is already a significant differentiator when you apply for roles. Skill 3: Clinical or regulatory exposure. AI is expanding fastest in drug discovery and clinical trials. Understanding how trials are designed, what regulatory frameworks look like, and how AI fits into that pipeline This is a blind spot most students have. A clinical research internship or even a course on GCP puts you ahead. The biotech professionals thriving right now are not the ones who know the most wet lab techniques. They're the ones who can move between biology, data, and context and tell AI where it's wrong. The biotech industry is changing faster than any of us expected. But that's not a threat, it's the biggest career opportunity in a generation if you know what to pay attention to. I'm going to be covering more of this on the channel. Career paths, tools, internships, the things that actually matter right now. So, if you haven't subscribed yet, now is actually a good time to do that. And I want to know which of these three skills are you most worried about: bioinformatics, AI tools, or clinical exposure.